All right, so this morning I finally have the machine installed. I have it all to myself. The tech has been here, but he's now gone and it's all set up and operational. So I want to give you a quick walk around of it. I think a little YouTube video is the way to do it. So starting at the vacuum pump, it's a 15 horsepower rotary vane vacuum pump, which means it has these carbon vanes that are kind of free floating in slots in this chamber. And as they rotate around, they slide out to the edge of the chamber and they kind of make a seal. So it's like a as the vanes wear down, they maintain their suction. Anyway, so here it is. The unit overall weighs about 800 pounds. The motor over here, which is bigger than it looks on video, is 410 pounds, and that's about 400 pounds for the rest of it. And I have it ducted in place. Got a filter unit, and then the air comes in and gets into a second filter unit, and then vacuum, then it exhausts. And this gets up to like 350 degrees. Pretty crazy. Like you can't hold your hand. This is like the X whatever, where the air comes out, and you can't hold your hand there because it's too hot. It's pretty cool. Turns out I set the thing too close to the wall, so I have to somehow move it over about 6 or 8 inches. Anyway, so here's the machine itself, and everything about the machine is just really overbuilt, which is super cool. So, like starting at the controller, you don't want the controller to tip over. So it's like, how do you do that? Well, this is just a 1-inch thick plate of steel, solid steel, 1 inch thick at the bottom, and the whole thing, and then it's just welded to a big tube steel frame. And that's kind of just the name of the game with this. So, like down at these feet, that's 3/4 inch thick steel welded. I think this is probably 1/2 inch thick steel tubing. You know, we got 1 inch thick steel plate here. All of the surfaces that should be machined are machined. So like here you can see that that's a machined surface with all of the linear guide rails are Rexroth brand, which is like a very premium brand. So it's kind of it's an interesting design. This is the y-axis here. The long axis is the y-axis. We have the gantry, which is sort of encircles the entire machine. So looking at it from the bottom, you can see it's a big tube steel frame for the gantry. And here are like the linear guide bearings, which have a bunch of little ball bearings in there that actually recirculate in sort of a pattern throughout the bearings. Underneath is kind of cool. Hop down under here. So this is the ball screw, which is very large. It looks like it's 1.5 or 2 inch ball screw. This is the ball nut, which is what rotates. You can actually rotate it and move the gantry. Pretty cool. This is the servo drive for the y-axis ball screw, which is a 3 horsepower absolute encoded servo. That's the ball nut back there. Under here we also have the valves for the zones of the vacuum system. So the vacuum system, which holds down material on the table, is directly in this steel tube. And then it just connects to these vacuum ports, which have these huge sintered, like bronze, I think, or brass sort of mufflers on here, which are they're They're crazy, huge. And it's all controlled by like it's all controlled electronically with solenoid valves, and somehow there's an air system in there too. So it's like pneumatic and also solenoid from the controller. Very cool though. Everything is, yeah, huge thick steel plates that are all machined. So coming back up, another just overbuilt element of this is like this tool rack. So this is like, I think that's at least 2 inches thick, if not more, solid aluminum, anodized, and it's not even water jet cut. This is all CNC machined aluminum, just solid, way overbuilt. So it obviously automatically picks up the tools. It has spots for 10 tools, and then it will come and automatically touch them off on the little touch-off probe. And that's how it measures them accurately. So in here you can see this is where the vacuum enters this steel tube. Over here is the control unit, which I guess I can open it up to show you what that's about. It's kind of cool in here. It's really well laid out. Let me see if I can get back a little bit to show you a little bit better. So it's really clean. The only thing that's not clean and tidy in here is the power coming in, which my electrician did a terrible job of. Terrible, horrible, have to yell at him for that. But besides that, it's, yeah, just super well organized. Everything is nicely labeled. You have your, like, these are all the breakers for the various electronics. Like for instance, this guy is a spindle fan, or the main power, etc. Then we have our inverter for the spindle, backup power supply, servo amplifiers. Everything is labeled and really nicely organized and laid out. So I'll go ahead and get this closed up. It opens and closes well, which is not always the case. I'll get it turned on. Okay, moving around it still. These are ISO 30 tool holders. So I just have, I have 6 of them right now. One is in the spindle. And I'll show you how that all works. Looking at the spindle itself, so we have bellows protecting the x-axis here, which are pretty nice. It's just Velcroed, like a heavy Velcro. And under there you have your ball screw, ball nut, etc. And then the servo drive for the x-axis is under that panel. It's kind of hidden within the steel tube of the gantry beam. Yeah, once again, just solid aluminum CNC cut parts. Like, this doesn't take any weight or anything, but they still make it out of whatever, half-inch solid aluminum plate, all nicely anodized. Looking at the Z-axis, so it's kind of cool. We have an air system, pneumatic system, that controls a handful of components here. One thing is just an air blast for tool changes on the spindle. It makes sure the spindle is clean when there's a tool change. You also have the dust hood here, the dust shoe, can go up and down. So basically, if you want to visually inspect your tool, make sure it's in properly, etc. Make sure it's not vibrating. You'll have your dust shoe up, but then when you're actually cutting, the dust shoe will be programmed in your program to drop down to better collect the dust. And you also have this pneumatic cylinder, which connects to this plate, which is just a counterweight for the spindle. The spindle is a 10 horsepower Hiteco spindle, which goes from like 1,000 RPM to 24,000 RPM. And it's really nice. And of course we still have ball screw on the Z-axis, big linear rails, big linear bearings. And then like here you can see the servo for the Z-axis, and I think this is just a 1 horsepower servo, which is still so overkill, you know. So that is sort of the overview of the mechanics, the super basic overview of the mechanical systems of it. One thing that's very cool is the encoders, or the servos, are all absolute encoded servos. So it knows exactly where it is at all times. You never have to home it or zero the machine, or you never have to be worried about running off the end, because it just knows exactly where it is at all times. So looking over at the control unit, it's a touchscreen control, but of course that's a pain in the butt. So instead, just use mouse and keyboard. It's very accurate. Those are inch measurements down to a 10,000th. And you can jog the machine. So here it's set in the 1/10,000th mode. So I can say move it in the Y-axis 1/10,000th of an inch. And you can see, really it looks like it's about 2 10,000ths. Yeah, 1/10,000th of an inch. Which you can see doesn't do much, but if you go up to, like, for instance, 1 inch, it does in fact move. And then you can also just do like a free jog. And you can, so I'm just holding down the Y-axis button, and you can see it just automatically stops appropriately. It's kind of scary, but yeah, it doesn't go off the edge. You can't really crash the thing. It's just too smart for that. Same with the Z-axis. Bring it up to the top. Normally, if you bring up your like axis or off all the way, you get all sorts of errors. You get an over travel, but here it knows exactly where it's at all times. Now I could crash the Z-axis into the spoil board, for instance, or into the table, because it has a tool on it, and the machine, it knows how long the tool is, but it doesn't care. It lets you crash it if you wanted to. So I'm still getting used to like the G codes and stuff, but you can say, for instance, S5000, 5,000, start, and then M03. And so this is just 5,000 RPMs. But as you can see, it's just dead smooth. And it goes up to 24,000 RPMs with no issue at all. This is 10,000 RPMs. You can't see anything, but yeah, it's very nice. What I'd like to do is I'd like to show you the vacuum pump. I think I got it all. It's all working really well now. The electrician had the switch kind of poorly adjusted. There's a circuit breaker in there, basically, that's variable. You can set the amperage that it cuts out at, and he kind of had it set too low. So as it got up to temperature, it was then tripping the circuit breaker. But go ahead and shut this buddy off. Jog mode. Okay. The spindle fan stays on all the time, which is just fine. Kind of loud. Yeah, so I'll show you the vacuum system because it's really cool, but it's gonna be loud when I turn it on. It's not that loud. It's not like anywhere near as loud as the ones I've used to work with, but it might be difficult to hear me talking on video. So it's a very cool system though. You have 4 zones on your table that can be actuated for the vacuum system. So if you just want just the 4x8 spoil board, or if you had a 5-foot by 10-foot spoil board, or if you just wanted one small section of spoil board, like one small section, you can activate the zones as required. So I'll go ahead and turn that on. I want to get a soft start for, or even a VFD for this vacuum pump, but whatever, down the road. There is running. So you grab a part, bring it over here. So whatever you have set on there, the larger the surface area, the more suction you'll get, but it's just totally movable. And there's no way that a person could now move that. And even a smaller part, you wouldn't be able to move. Then you can shut that off, and it moves just fine. It's magic. So, you aren't actually supposed to turn the vacuum on and off frequently. You're supposed to let it run for like, you're not supposed to turn it on and off more than like 5 times an hour, basically. Anyway, so that is the overall of the CNC machine. It's really accurate. I've just cut like one test part. It was within 1/1000th of an inch of accuracy. And then I was a little bit worried about the tram of the spindle, but I resurfaced the table using a fly cutter, which is that guy. It's kind of a wider bit, used specifically for either like milling slabs or resurfacing this. And you can tell just by the fact that there's no lines in the table as the cutter went back and forth that it's pretty much perfectly, as good as I've ever seen. Yeah, perpendicular and plumb to the table. Okay. Thanks for coming to my TED Talk.